Danger! I'll be doing reactions that produce deadly fumes, and I'll be handling corrosive acids in this video. My work will be done in a fume hood to vent the deadly gases away from me. Doing these reactions in an enclosed area or without proper safety equipment could cause serious injury or death. Hello YouTube, welcome back to my channel. I'm Sri Tips. Today what I have is some inquarted gold that's been inquarted with sterling silver. I added too much sterling silver to the carat gold to make up the alloy, and as a result, during the hot dilute nitric acid treatments, the gold crumbled, fell apart, and turned into a powder. This creates problems, several problems, the first of which is there's going to be suspended gold in my hot dilute nitric solutions. So I can't just pour them off like I have in the past. I have to wait, sometimes for hours, for the gold to settle out, and then I can draw off the silver-bearing solution off the top of the gold. Second problem is when I go to dissolve the gold after I've removed all those hot dilute nitric acid treatments, some of the solution will tend to cling to the gold. That solution will have silver in it. As soon as I try to dissolve that gold with the silver solution clinging to it, I'll get a bunch of silver chloride formation in my gold, which is undesirable because it will load the filters up, make filtering difficult, and silver chloride is somewhat soluble in these solutions. And what they'll do is they'll hide out in the solution. The solution will look clear and bright, but it will have silver chloride in it, dissolved. And the only way to get it out is to chill it down and filter it out. Also, silver chloride is a very fine material that will pass right through a filter paper. So what we're going to do right now is show how to process the gold that's been over inquarted with silver. We'll do that right now. These next 3 clips are from previous videos where I inquarted gold with silver and then used hot dilute nitric acid to extract the base metals and silver. Notice how the gold holds together and allows me to quickly and easily pour off those hot dilute nitric solutions. This is how the gold should look when we add the proper amount of silver for the inquartation. Okay, here we go. This beaker here is the subject of this video. It contains inquarted gold that had the improper amount of silver added. I added too much silver, and as a result, when I put the hot dilute nitric acid on it, the gold, instead of staying in nice firm chunks, as you've seen in previous videos, it caused the gold to crumble, come apart in pieces, and form a powder. This makes removing the silver-bearing solution sitting on top of the gold difficult. I can't pour it off quickly and easily like I did in previous videos, so I'm using a vacuum suction tube into a filter flask to get the solution off there. This is an undesirable condition and something that we want to try to avoid, and I'm going to demonstrate how to recover from it. I've got all of the solution pulled off of the granules up here. So now what I'm going to do is get this out of the way. what we'll do is add some distilled water to our granules up here. Notice how we get a bloom, a cloud of gold powder in there. The chunks came apart from the improper amount of silver added to it. This will be my last nitric acid treatment here. We'll put this up on the heat and let that cook and dissolve out the rest of the silver and base metals. I've been working on this for several days now, and as you can see, the chunks of gold have come apart and formed a powder that stays suspended in the liquid. So what I'm going to do now is let this settle, and then I'll draw this liquid off. This is one of the problems that occurs if we add too much silver or copper, whatever the case may be, to inquart the gold. Alright, I'm trying to get a shot of this, the color of this liquid. It's got a pale purple color to it, which tells me that there may be some colloidal gold suspended in the solution. And this is why it's important to make sure that we add the correct amount of metal to inquart our gold. Adding too much will cause the gold to crumble and form a powder and make separation of liquids difficult. It's been about 6 hours since I removed the quarted gold from the heat, and as you can see, there's still just a tiny bit of suspended gold in here. I think it's going to be okay. I'm going to go ahead and draw this off now. This is the big disadvantage that happens when we add too much silver. It just slows everything way down. We've got to wait for everything to settle out before we can proceed. The main problem here is this solution is going to have silver in it, and it's mingled and co-mixed with the powdered gold. And so what we want to do is get this silver out of here before we go to aqua regia. Put some hydrochloric acid here now, and you'll see that a cloud of silver chloride will form. And we want to get all that silver out of this liquid before we put this gold in aqua regia. That's the problem we're trying to solve here. Alright, here we go. We're going to draw this liquid off with my vacuum tube here. Here's our inquarted gold. Notice how it's formed like a mud in there. And the liquid that's in there with it is going to contain silver. So I want to try to get all that liquid out of there, or at least get the silver rinsed off of these pieces before I add aqua regia. The hydrochloric acid in the aqua regia will combine with the silver in that solution, form a whole bunch of silver chloride, and cause a lot of problems for us later on here in the process. I've got some distilled water heating back here. This is my gold that's still got silver solution mixed in with it. And what I'm going to do is I've got a Buckner funnel here and another one that fits down into it perfectly. I've used this method in the past with good results, so I'm going to employ it here. I'm going to use this funnel as a pattern and make a fitted filter paper. Here we go. I'm going to transfer my gold into this filter now. Alright, now I'm going to light off the vacuum pump, start pulling that solution out of the gold. As you can see, I've got a little bit of color coming through. It's got just a little bit of a purple tint to it, which tells me this is colloidal gold. Gold that's so fine that it passes right through a filter paper. Another problem with adding too much silver for the inquartation. We're going to pour it through here and try to rinse this gold off with some hot distilled water. Here we go. The goal here is to get the silver rinsed out of this so that we can add aqua regia to it and not have a bunch of silver chloride forming in there. Okay, the solution looks like it's starting to run clear now. So I'm going to swap out the flask here. Distilled water here going in. Try to get all that silver rinsed off of this gold. Alright, I got a clear solution down here. Hot distilled water. And what I'm going to do now is take this funnel off. Set it up here on this large flask. Just get it out of the way. Take a little bit of this water down here, and I'm going to add a little bit of it to this beaker. And what we're going to do is do a test on this water, this rinse water that came off the gold, with hydrochloric acid, and see if we get silver chloride forming in this rinse water. I don't see anything. I think we're going to be good to go here. I don't see any silver chloride forming in there. So I think I pretty much got all the silver rinsed out of our gold. I've been working on this gold for about 3 days now. Taking my time, trying to get all the silver out of there. And I think I finally got it. So what I'm going to do now is get this gold to this beaker, and then I'm going to add some hydrochloric acid to it. Well, I'm going to fill it up to about the 400 milliliter mark there. Hydrochloric acid going in. Let's see if we get a bunch of silver chloride forming here. I don't see a whole lot. That's about 3 or 3.5 troy ounces of gold in there. As usual, I'm going to add some concentrated sulfuric acid here just in case there's some lead in there. That's about 1.5 milliliters concentrated sulfuric acid. I'm going to add some concentrated nitric acid here to form aqua regia in there. 1, 2, 7, 8. That's going to be about 24 milliliters of concentrated nitric acid. Cover this up, give it a little swirl to shake it up, or mix it up. And we're going to put it up on the heat here and let it dissolve. Gold has been in there dissolving now about 20 minutes or so. I'm going to add some more nitric here. See if I can light the reaction back off here. It's nice and hot, so you got to add it slow. All right, we're going to take a look at our solution here underneath. And if you can see there, I've still got a bunch of gold on the bottom of that beaker. Looks like some silver chloride as well. So we're going to continue to add nitric acid here until we get everything to go in the solution. Adding some more nitric here. See if we can get the rest of the gold on the bottom of that beaker to dissolve. It is the following morning. I came out this morning and my solution back here is all settled, nice and clear. But before I go any further, I need some of these flasks for the next process. This is the distilled water hot rinse of the Inquarted gold. I don't add any of this stuff to my stock pot because it's going to have silver in it. So I'm going to add it to my silver jar here. If I tried adding these solutions to my stock pot, it would end up forming silver chloride in my stock pot, and that's an undesirable thing. So I'm going to add all this into my silver jar here, and then this will be cemented out with copper. Any gold that I rinse in here will get filtered out when I process the silver. When I process the solution for silver content, the first step is to filter it out. So any gold that gets added in here will be recovered during that filtering process. This one here's got a light dusting of gold on the bottom of the flask, but the solution has silver in it, so I don't want to add this to my stock pot. It's going right into here, into my silver jar, and like I said, I'll get that gold out when I recover the silver. First step in recovering the silver is to filter this solution, and when I filter it, I'll get the gold back. Alright, if you look here, you'll notice that the suspended gold is floating on top of the solution. Down here it's cleared blue, which is kind of an unusual phenomenon as we get set up here to filter our gold solution. Now I'll take our gold solution back here that's been cooled off all night. See how clear it is? All the material on the bottom there is mostly filter paper. So now we're going to pour it through this filter and filter all the solids out of this gold solution. Notice how the filter paper helps me here down in the bottom of that beaker by retaining any solid material, allowing me to pour off the clear solution into the filter. And now what I'm going to do is pour the solids in here and get the rest of the solution off of these solids. This is going to load the filter paper up and slow the filtering way down. It's slowed down now to just drips. It's coming through there pretty good, but I've got a whole funnel full of solution that has to be pulled through that filter paper and the other solids that have accumulated to load the filter paper up. It's going to take a while, and this is another disadvantage of having a bunch of silver chloride in with the gold. It slows the filtering process way down. The solution has been filtering under a vacuum now for about half an hour. I just wanted to show you how much it's slowed down here. I got just drips coming out of that funnel now. I remember when I first started refining, I used to just throw everything right into the filter. Sometimes it took hours for all of the solution to be pulled through that filter. I'm finally down to the solid material there in the funnel. It's been filtering for 2.5 hours now. And as you can see, I'm still just getting a few drips. About one drip every 15 or 20 seconds or so. And I've still got to rinse the funnel out and get all that liquid forced through it. So this is why we want to avoid having a whole bunch of silver chloride in with our gold. It slows the filtering way down. It's 6:30 p.m. I've been filtering this solution now for 8.5 hours. I get one drop literally every 5 minutes. It's a matter of diminishing returns now. What I'm going to do is take the filter off of here. It's still got some solution that contains gold, but I'm going to transfer the liquid. We've got most of it down here in our flask. I'm going to transfer the liquid now into this beaker so we can precipitate out the pure gold. I've got about 3 or 3.5 troy ounces of gold in here. Whenever I have that much, I always add some ice. Now we're going to use some sodium metabisulfite and precipitate out the pure gold. Got everything to come out of solution now. Add one more spoon here and see what happens. That's looking like we got everything precipitated. What I'm going to do is get a stannous test. Make sure we got all the gold out of our solution here. And as you can see, no reaction. All the gold has been precipitated out of our solution. Here I'm pouring off the waste solution into that flask. That'll be added to my stock pot later on. And then I get the gold down into a filter paper so we can get it melted. I've rinsed the gold with some hydrochloric acid and then distilled water. And now what we're going to do, we're going to get it out of this funnel here and into a melt dish. Get it over on the melt table and get this thing melted, get it out of our hair, get it over with. Alright, let's get it over here on the melt table. We'll melt this up into a bar and then get it ready to ship off to the refiner. Here's our pure gold bar. Probably 99% pure. You can see some irregularities in the surface there. That's probably some silver from that silver chloride that came over before I precipitated the gold. Now we're going to get a weight on this thing, see what we got for a weight. It's 104.0. It's 3.3 troy ounces of pure gold, probably 99% pure here. This will conclude the video. I've got my 3.3 troy ounce bar here. I did not do a second refining because this is going to go into the refiner, the big refiner I sell to, and he'll just throw it in with his next batch and re-refine it. So there's no need to go with high purity here. We did see, however, how important it is to calculate the correct amount of silver when we go to inquart our gold. If we add too much silver, it falls apart, and we have all the problems that I had in this video. It took me 4 days to get this thing. I'm glad to get it over with. On the other hand, if we don't add enough silver, then the nitric acid will not be able to penetrate, and we'll have a whole host of different problems. Alright, we got our gold out. I hope you learned something from this video. Thanks for watching.